This training video outlines the steps to create your first pneumatic or electro-pneumatic circuit in Automation Studio. In the process of recreating this circuit, the user will learn how to create a pneumatic circuit with generic components from library, how to do circuit addition, how to assess component properties and help, how to create a control sequence, and how to run simulation and analyze the circuit. All components needed to build your first pneumatic circuit are contained in the main pneumatic library. In order to create the circuit, move the components from the library onto the schematic. To do so, select the desired component from the library, in this case a pneumatic pressure source, and drag and drop it onto the schematic while holding down the left mouse click. Similarly, drag and drop a double acting cylinder, a 3x2 way normally open directional valve, a 5x2 way directional valve, and 3 exhausts. To zoom in the schematic, go to the View tab of the ribbon bar and click on Zoom in function under the Zoom tools. Other zoom functions like Zoom Page, Previous Zoom, Zoom All Components can also be found at this location. Alternatively, to zoom in and out, press and hold down the Control key, then scroll up to zoom in or scroll down to zoom out of the page. Software will zoom where you are pointing your cursor. To pan the document, click on the panning function of Zoom tools. When you click on the panning function, the cursor transforms into a hand icon, and then you can pan the document by holding the left mouse click and moving the cursor. Alternatively, you can press and hold down the space bar and move the cursor to pan the document. To disable this function, just right-click on the document. Now, establish connection between these components to create the pneumatic circuit. To connect components, move your cursor over a red connection port and click when the target sign appears. Release the button, draw your line with the cursor, and click on a second connection port to establish connection between those two components. Both connection ports automatically become black when linked. Similarly, connect the working port of the 3x2 way valve to the pressure in port of the 5x2 way directional valve. In order to connect the exhaust to the directional valve, select an exhaust and drag and drop its connection port over the connection port of the 3x2 way normally open valve. Similarly, connect the two other exhausts to the 5x2 way directional valve. In order to connect the working ports of the 5x2 way directional valve with the cylinder, you need to change path during connection. To do so, when drawing a line while moving your cursor, click when you need to create a 90-degree turn and connect. Similarly, connect the other working port of the directional valve with the cylinder. Now that all the components are connected, you can start the simulation. Go to the Simulation tab of the ribbon bar and click on Normal Simulation icon under the Control functions to start the simulation. While in simulation, when hovering over a component, if the cursor turns into a hand icon, you can click to interact with that component. Here, by clicking on the push button command, position of directional valve is changed, which results in extension of the cylinder. On releasing the mouse, directional valve moves back to its initial position, which results in retraction of the cylinder. While in simulation, you can also view a cross-section animation for any component shown in red, such as cylinder. Simply right-click on component and select animation. You can see the animated view on a separate window. Close the animation window and stop the simulation by clicking on Stop Simulation icon under the Control tools. Now let's learn how to change the technical properties of a component. Insert a mechanically piloted 3x2-way normally open valve from the main pneumatic library. Now add another mechanically piloted 3x2-way valve on the schematic. You can add the valve by drag and drop operation or directly copy the valve already available on the schematic. To do so, simply right-click on mechanically piloted valve and select copy. Then right-click on document and select paste. Note that the component will be pasted where you are pointing your mouse cursor. You can also use a shortcut to duplicate a component. Press and hold down the control key and drag the component anywhere on the schematic. If you need to change the visual representation of a component, functions to rotate, flip, align, distribute, and order components can be accessed from the Edit tab of the ribbon bar under the Layout tools. Just click on the component and select desired functions, or right-click on component and select desired manipulation functions, or simply use assigned hotkeys. To visually adjust the component layout before doing connections, click on a mechanically piloted directional valve. Then click on Position function in the Layout tools and select Rotate left 90 degree. Then from same menu choose Flip vertical. Now click on the copied directional valve and select Rotate right 90 degree. Again from the same menu choose Flip vertical. We need this mechanically piloted directional valve to switch its spool position when the cylinder is fully retracted. To do so, move the directional valve to match position of diamond at the end of the cylinder with the diamond on the mechanical sensor of the directional valve. Now, position the mechanical sensor of the second directional valve at the end of the cylinder's stroke. For that, you need to access Component Properties window of cylinder. To open the Component Properties window of the cylinder, right-click on it and select Component Properties. You can also open the Component Properties window by double-clicking over the component. Select Data from the left side menu and change the extension to 100% and close the window. Now move the second directional valve to match position of the diamond in its mechanical sensor with the diamond at the end of the cylinder's rod and reset the cylinder's extension to 0%. To slow down the cylinder's extension, you need to adjust the diameter of the pressure source. For that, double-click on the pressure source and adjust the orifice diameter to 0.6 mm and check the box next to it to display the value on the editor. Please note that adjusting technical data in the component properties do not impact the visual aspect of the component. All components in Automation Studio also have a help file describing their functionality. Right-click on component and select Context Help. In this window, you can get information about the operation of the component and its features. This window also provides description of each property of the component available in the Data tab of its Component Properties window, such as properties related to its modeling, characteristics, external data, operating conditions, and so on. You can also access the help file by clicking on the component and pressing the F1 key of the keyboard. The 5x2-way directional control valve is currently controlled by a push button or a solenoid. But for the pneumatic circuit, you need an external pneumatic pilot command instead. To change the command type, double-click on the directional valve to access its component properties window and select the builder from the left side menu. Click on the push button and click on delete. Now double click on the spring return to open command selection window and select external pneumatic pilot command and apply. To modify the position of the external pneumatic pilot command as per your need, use these arrows. Similarly, replace the left solenoid by external pneumatic pilot command. Click on green check button to apply the changes and close the window. Now to complete the circuit, drag and drop two pressure sources and exhaust on the schematic. Select the first pneumatic pressure source and the exhaust while holding down the shift key. Then go to the Edit tab, click on Position under Layout Tools and select Rotate Left 90 degree. Similarly, select the other pneumatic pressure source and the exhaust. Go to the Position tab and click on Rotate Right 90 degree and complete the connections in this fashion. To create these lines as pilot lines, right click on the line and select line functions and click on pilot. Repeat the same procedure for the second pilot line. You can also add measuring instruments in the circuit. Add two pressure gauges from the library to take pressure reading during simulation and connect them at the two ports of the double acting cylinder. Now add a flow meter from the library and place it between the two main directional valves of the circuit to measure flow. When adding a component directly from the library, you can drop it onto a line and it will automatically get inserted into the schematic. Now that measuring instruments have been added, start the simulation to see how the circuit will react. The cylinder extends when the simulation starts since this directional valve is open and the pneumatic pilot line pushes the 5/2 way directional valve in position 1. When the cylinder reaches the end of its stroke, this directional valve gets open and the 5/2 way directional valve returns to position 2, causing the cylinder to retract. This directional valve acts as a safety valve. When you click on the push button command, the circuit air is evacuated to the exhaust and the pressure source is disconnected. Stop the simulation. Now let's create the electro-pneumatic circuit. Before that, go back to your original circuit. For that, you need to delete the components added later in the original circuit. Firstly, disconnect the flow meter from the circuit. For that, press and hold down the shift key, click on the component and drag it elsewhere on the schematic. Now to delete this flow meter, right click on it and select delete. Now select all the other components to be deleted one by one while holding down the shift key. And press delete key of your keyboard. The 5/2 directional valve is currently controlled by pneumatic pilots, but for the electro-pneumatic circuit you need two solenoid commands instead. To change the command type, double click on the directional valve to access its component properties window and select the builder from the left side menu. Double-click on the left external pneumatic palette command to open command selection window and select solenoid DC-AC and apply. Similarly, replace the right external pneumatic palette command with the solenoid DC-AC command and apply the changes and close the window. Now, for the position reference of the cylinder, sensor needs to be added in the schematic. For that, click on the small triangle besides Pneumatic Library to open the Pneumatic Library tree. Select Sensors and drag and drop to Sensor Reference and give them alias A0 and A1. The alias of a component is displayed on the schematic and is used to identify the component by linking it with other components. Position the first sensor above the piston with an extension of 0%. Double-click on the cylinder to assess its component properties window and set the extension to 100%. Now position the second sensor above the piston and set the extension back to 0%. The 5x2 valve has now been transformed into an electrically controlled valve, and the question mark symbol above the solenoid signifies that it needs electrical input signal to change its spool position. In order to provide the electrical signal for valve operation, you need to create a simple electrical control circuit. All the components needed to create this circuit are available in the electrical control library. Select either of the electrical control library, for example electrical control JIC standard, and drag and drop a power supply 24 volt, a common 0 volt, a normally open push button. When inserting an electrical control component on the schematic, the software asks for an alias for the component which is displayed on the schematic. And this alias is used to identify the component by linking it with other components. Let's give it an alias PB1 and apply. Similarly, drag and drop to normally open proximity switch. To solenoid DC-AC and give them alias A plus and A minus. Now drag and drop a coil and give it alias C1 and a normally open contact. Connect all these components to complete the electrical control circuit. You can rearrange a component's position by hovering the cursor over the component and move the mouse while holding the left click. While tracing a line coming across another line, there is no target sign that usually allows you to make a connection. Therefore, you need to double click on the line to make a junction. When a 3-line junction is created, a fill black connector is automatically created at the junction. Complete the circuit by inserting junctions. Now link both solenoids of the directional valve with the respective electrical solenoids of the electrical control circuit. Double-click on the directional valve to open the component properties window. Click on the variable assignment from the left side menu. Click on the left solenoid icon of the directional valve. Use the filter from the compatible simulation variables section to sort the variables and only show the one matching your criteria. Here, left solenoid of the pneumatic directional valve has to be linked with the solenoid of the electrical control circuit which has alias A+. So write A+ in the filter. Once identified, double-click on the alias to create the link. You can observe question mark symbol has been replaced by A+, confirming that the link is created. You can also see in the association span that now there is an association between the two components. Similarly, link the right solenoid of the directional valve with the electrical solenoid having alias A-. And close the window. Now link the two normally open proximity switch with the sensors of the pneumatic circuit having alias A0 and A1. And link the normally open contact with the coil C1. Now that the links are made and the aliases are the same between the pneumatic and the electrical components, the circuit is ready to be simulated using both the technologies. Start the simulation. Click on PV1 and latch it in order to activate the push button and energize the solenoids. Observe that the directional valve changes the position as the cylinder successively extends and retracts and reaches a proximity sensor, resulting in an automated extend-retract loop for cylinder. In this way, you can create different pneumatic and electro-pneumatic circuits.